My name is Paul, and I'll be taking you through the research to find out whether citizen science data, which are referred to as C-Science and so on, or manual surveys, or this is better for understanding ecological patterns of birds. So the citizen science data here is the data collected from eBird, and manual surveys is the surveys done specifically for the project, and the automated data collection was through camera traps. And I'll give you a background of the study itself. To give a brief background of the study, collection of ecologically significant information of natural history was restricted to just manual or in-person method of fieldwork in the past. This has changed dramatically with the invention of technologies such as trigger-based camera sensors and initiatives like global C-Science databases, which are regularly updated. In the current study, I will compare the usage of eBird data from the field study in Bilaspur district located in the Shivaliks of Western Himalayas with structured, manual and sensor-based avian surveys for ecological understanding of temporal and spatial patterns of birds, such as daily activity period. As you can see, this is the sampling map with the stratified random sampling sites with the camera traps located within it. Date of first and last detection can give an indication of date of arrival or departure of migrants as well as residency status of resident birds. So we'll look into how the date of first and last detection differ from the three methods of data collection, that is through autonomous recording device, a camera traps, which includes image, video, and audio, and then manual surveys, and as well as C-Science data source, which is eBird. To understand this, let's look at the distribution of data points across the dates for three methods in the following box plots. As you can see, the distribution is quite erratic. It is clear that no two species have the same pattern of distribution of data from the three sources, and it's very difficult to see any common pattern that emerge from it. However, at first glance, a manual survey seems to do consistently better in detection across the study duration. Let's see if this holds true after some number crunching. The following data table highlights the number of data points which are closest to the benchmark value from different methods, that is standalone and in combination with others. The benchmark is taken as a combination of information from all three methods, since that is what will give the most ecologically realistic value. The second last row shows the number of data points closest to the benchmark for species that occur in at least two sources. That is sometimes not in eBird. And the last row is the same except for species occurring in all three sources. We can see that the inequality from best to the least good in both cases, the combination of manual surveys and eBirds, followed by manual surveys only, and then by camera traps plus eBird, and then by camera traps only, and finally eBird only. The past 4 years of data from eBird in the same time of the year mainly adds two more significant data points, indicating that in sparsely bird areas such as Bilaspur, the C-Science data alone is insufficient to do any ecological investigation. In case of many resident species, it has been shown that they were present during the entire period, as should be the case. However, eBird merely added 5 more significant data points. For example, the grey hornbill to the combination when compared to the manual surveys alone. So individually, manual surveys are still the best way to understand date ranges since they are consistent. Individually, considering the data from eBird for the past 5 years during the same time frame, that is January to April, shows that it merely adds an extra 2 significant data points. By considering data beyond 5 years may add some more data points, which is likely to confirm the results with complexity, since beyond that point, the changes in migratory patterns due to causes such as climate change would likely have been negligible or different. The following range plot combines data from three sources to determine the most realistic days of arrival, departure, or conspicuous activity from the district. Note that the non-detection of a resident species in the area may be an indication of the breeding rate. So such range plots across an year can provide such hidden information. Now we are moving into the second part of the temporal patterns, which is time. Time of first and last detection can give an indication of daily activity patterns of birds. To understand how the time of first and last detection differ from the three methods of data collection, let's look at the distribution of data points across the dates for three methods or sources in the following box plots. As you can see, in the case of the fulvous-breasted woodpecker or the Dendrocropus macy, the combination of manual survey and camera trap data is most suitable for understanding the time value range, since there is almost no overlap between them. So to understand the differences between the three sources of information, one must convert the data into usable components. Since both eBird and manual surveys had surveys conducted over a period of time, for example, 10 minutes to 1 hour, there are three possible time data that can be derived: time at the start, middle, and at the end of the survey. This is then used to represent the time a species active from and to Since there is a time duration in both eBird and manual surveys, for example, 5:58 a.m. to 4:07 p.m. for Jungle Babbler and manual survey, and the time data is exact for camera traps, the first step is to decide what to use for the comparison, whether start, or mid, or end time. For this, a one-way ANOVA of the from and to time data of species for three possible options were carried out to check for any differences in mean. In all the four cases, that is from and to data of eBird and manual surveys, it was found that there are no significant differences in means. The following slide shows the data tables for the same. This means that start, mid, or end times can be used interchangeably. For this reason, I selected mid time for both the eBird and manual surveys along with time values from the camera traps to compare their means. In this case, however, it was found that there was indeed a difference of mean, as you can see in the table above. To find out amongst which of these lies the difference, pairwise t-test was carried out and the result was as shown in the table below. It is clear that while there is no significant differences amongst the means of data from manual survey and eBird, data from camera trap differed significantly in mean from that of manual survey and eBird. But in this case, which data or combination of data is for best use? Given that camera traps have a very high temporal resolution, it seems like the best option. However, the detection probabilities for camera trap is most likely lower than the other two due to its stationary nature and limited field of view or hearing. So a combination of data from checklist with smaller duration from eBird and manual surveys as well as camera traps is suggested. The following range plot shows the distribution of daily activity of birds during the study period, which was a winter. This can vary across the seasons. Let's look at the second aspect of the study, which is spatial data. Since species distribution models such as Maxent are sensitive to spread of background sample data, the source of data also affects these models. For this current study, a comparison was made between models constructed using eBird data, manual survey data, and a combination of these two. The camera trap location were too sparse to add any value, as only 9 were functional and most didn't detect species. The environmental data were selected from a pool of 64 variables, as you can see in the following slides. These are the variables, and these are representation of some of these variables. This is CHILSA bioclimatic variables, and this is a representation of MODIS land use data. So a combination of PCAs, correlations, jackknifing, the 64 variables were whittled down to 11 to 15 variables for different models. The results, the species distribution models, as you can see, the data is clustered towards the right side. In case of manual only, this is because the species was located in those areas only during the study period. While in case of eBird, since the spread of data points, which are represented by the black plus signs, is spread across, the suitability was also found to be higher. A combination of both of these gave a better model, and a histogram of frequencies of pixels relating to probabilities of suitability of habitat for the species Verditor flycatcher is shown here. And as you can see, the eBird model was very similar to a combination of manual plus eBird, which is considered the benchmark. This is because of the spread of data across the study area in case of eBird. As you can see, if you consider 0.7 as a threshold, the number of pixels that is equivalent to the suitable area is almost the same for both eBird and manual plus eBird combination. To conclude, a combination of the three sources are better. But in a case where there is a budgetary constraint, a combination of manual survey plus eBird data is sufficient for a good understanding of temporal and spatial patterns. It is my recommendation that the contributors to eBird submit their checklist in durations of 1 to 20 minutes as well as 1 to 200 meters, so that they have a higher spatial and temporal resolution, which can be used to better model species, such as in this case, I'm showing you a map of habitat classes which would read high resolution eBird data for modeling. And that is all. Thank you.